Hello everyone. Today I am going to solve some questions from previous year question paper of geophysics. So I am coming with I came with some questions from previous year question paper of 2022. So let's see first question from differential equation, and question says that solution of equation differential equation this is. So let's see. The given differential equation is x dy over dx plus 2y equal to x cube cos 4x. So we can see that this is a familiar differential equation. So divide by this equation by x, which we get dy over dx equal to 2 over x equal to x square cos 4x. This is a linear first order differential equation. Compare with dy over dx plus px into y equal to qx. So here px equal to 2 over x and qx equal to x square cos 4x. And the solution of linear differential equation is given by into e to the power integration px dx equal to integration e to the power px dx into qx dx plus c. So e to the power integration px dx, what will be? This will be e to the power 2 over x dx. When we solve this, we will get e to the power log e base e x square, which is equal to x square. So solution will be by into x square equal to x to the power 4 cos 4x dx plus c. When we integrate this by parts, we will get by equal to x square sine 4x upon 4 plus x cos 4x upon 4 minus 3 sine 4x upon 16 minus 3 cos 4x upon 32 x plus 3 sine 4x upon 128 x square plus c1 over x square. So this will be the solution, and you can see there is no answer is matching from this solution. So in exam you can see an answer key also that there this question has been dropped due to no answer is correct. So now next question is from differentiation under integration sign. This question is from differentiation under integration sign. So you have heard about Leibniz rule. This states that f x comma t dt equal to d over dx which is equal to integration del f over del x f x comma t dt plus f upper limit in place of t, sorry, in place of x comma del psi over del x minus f phi of x comma t d psi over dx. We apply this rule in our question, we will get d I over d alpha equal to a to b df over d alpha into dx plus f of b comma a dv over d alpha minus f a comma alpha d a over d alpha. So B option is correct. Now next, come to the next question. This question is from Fourier series. So first statement is that even function can have no sign terms in Fourier extension, and another statement is odd function can have no sign term in Fourier extension. So we know that the Fourier series of even function is given by f of t equal to a naught upon 2 plus summation n equal to 1 to infinity a n cos n pi t over L, and for odd function it is given by f of t equal to n equal to 1 to infinity bn sin n pi t over L. So from this and this we can consider these two statements. Here you can say the even function can have no sign term in its Fourier expansion. So you can see there is no sign term, here is only cos term is there. So first statement is correct, and Fourier series of odd terms is given by bn sin n pi t. So there is sign term, and statement is saying that there is no sign term. So this statement is correct, false. So option C is correct. Statement 1 is correct. Another one is incorrect. Now come to the another question, which is the application of differential equation. We have seen the result that v equal to ir plus l di over dt. You have heard this in differential equation or in electronics. So here v equal to given, it is given 40 watt, l equal to 2 Henry, and r equal to 10 ohm. Put these all value in our differential equation. 40 equal to I r equal to 10 plus L equal to 2 and di over dt. So this is a differential equation. 2 di over dt plus 10 I equal to 40. So solve this equation. Di over dt plus 5 I equal to 20. So this is again a linear differential equation with px equal to pt equal to 5. So solution is given by I e to the power 5t equal to 20 e to the power 5t integration dt plus c. So it is given by I into e to the power 5t equal to 4 e to the power 5t plus c. So when we get I equal to 4 plus c e to the power minus 5t. When we solve this for t equal to 0, it is 0. So this is given by 0 equal to 4 plus c, which implies c equal to minus 4. So I equal to 4 minus 4 e to the power minus 5t, which is equal to 5 4 1 minus e to the power minus 5t, which is third option is correct. Now come to the another question. This question is from vectors, which is read this question. For a field f equal to grade g, satisfying the assumption of divergence theorem for f and g as scalars. So Green's second formula can be written as, so first of all, what is Green's second formula? Green's second formula is this: over region d, u gradient v minus v gradient u dx equal to boundary of d u dv over, sorry, del v over del n minus v del u over del n ds. So put u equal to f and v equal to gradient of g. So put these value in our formula. We will get t f del square g minus g del square f dv, sorry, it is dv equal to s f del g over del n minus g del f over del n into dA. So your fourth option is correct. Now come for the another question, which is also from vectors. Here it is given that f equal to f dot grade g. Now we have to find its divergence. So it is there is a property which is given, that divergence of gradient of g equal to Laplacian of G, and another one is divergence of F and F into G equal to F dot divergence of G plus gradient of F into G. So apply both these property, we will get F divergence of G. What we get? We will get here our G is equal to gradient of G. This is G, this is F. So we will get F gradient of Laplacian of G plus, according to this identity, gradient of F into what is G? Our gradient of G. So this option should be correct. Now come to the another question. This question is again from vectors. Here is a famous result that curl of gradient of F equal to 0, and another question is another result is divergence of curl of F equal to 0. Okay, so from these results our option C is correct. Curl of gradient is 0. Now we have solved this question above. In that question we will find we have found divergence F of gradient of G. There also we have get that F gradient of G square, gradient is of G plus gradient of F into gradient of G. So fourth here fourth option is again correct. Now come to the another question. Here we can say that we can see that the t equal to G at t equal to 0, the for any radioactive substance is 0.5 gram. So by 0 equal to 0.5 for t equal to 0. So we know that the rate of change of radioactive substance is directly proportional to by, which is equal to dy over dt. It is decaying, so minus k by t, where k is still greater than 0. So we will solve this differential equation, which is variable separable. So on solving this equation we will get by d by over by t equal to minus ka k dt, which, so on solving this we will get ln by equal to minus k t plus c. On solving this we will get finally by equal to c e to the power minus kt. For initial condition by 0 equal to 0.5, so this implies c equal to 0.5. This implies by equal to 0.5 e to the power minus kt. So C option is correct, I think. Yes, yes. Now to the another question. Yes, this question is again from vector calculus. There are lots of questions from vector calculus. So we will solve this. This integral is given in cylindrical coordinate. So in cylindrical coordinate we know the formula that volume is given by r square sine theta dr d theta d phi. Here any function f r theta phi. This is the limit of r, this is theta, and this is phi. So put all these values according to question. We will get v equal to, here our f equal to r square cos theta. So this will become r to the power 4 cos theta into sin theta dr d theta d phi, and the limit is r, limit of r is 0 to 2, limit of theta is 0 to pi by 3, and limit of phi equal to 0 to 2 pi. So we will solve, first integrate with respect to r. We will get the applying limit, which we will get 32 upon 5, and multiply 2 and divide by 2. So we will get, this will become sin 2 theta. So this will become sin 2 theta upon 2 d theta d phi. So we can see there is no term of phi, so we can multiply 2 pi directly, and integrating this with respect to theta, we will get 32 upon 5 into 3 by 8. So on solving this, we will get 15.079, which is nearby 15. So D option is correct. Now come to the another question. This is from differential equation, and we know that x naught is a singularity. This is a definition that if px and qx are diverges, but limit x tending to x naught, x minus x naught px, and limit x tending to x naught x minus x naught square into qx, both remains finite. So then x naught will be a singularity. So option B is correct. Now see, this question is from complex analysis. So we know that z over z minus 1 z plus 3 square. So what is the definition of pole? The definition of pole is that z minus z naught into fz limit z tending to z naught is finite and not equal to 0. Then z naught will be a simple pole. So here we can see that put this equal to 0, so z equal to 1 and z equal to 3 minus 3 will be a solution of denominator. So z minus 1 fz, z tending to 3 z tending to 1 is finite. So z equal to 1 will be a pole. Similarly, z minus z to the power square fz is again finite. So z equal to minus 3 is a double pole. Limit z tending to here. So there are two poles, z equal to 1 and z equal to minus 3. So answer B is correct. Now come to the another question, which is a limit question from limit. So limit n tending to infinity 1 by n 1 over n. So write this question. We know that log e to the power log a is equal to 1. So we can write this e log e 1 by n to the power 1 by n. Limit remains same and tending to infinity, which is equal to e to the power 1 by n log 1 by n and limit n tending to infinity. So this will become e limit n tending to infinity ln 1 by n minus upon n, which is infinity by infinity form. So we can apply L'Hopital rule. So we will get on after we applying L'Hopital rule, n tending to infinity 1 over n upon 1, which is equal to e to the power 0, which is equal to 1. So limit of this equal to 1. So D option is correct. Now come to the another question. You have seen Euler's identity or Euler's theorem for trigonometry. You have seen that sine z equal to e to the power iz minus e to the power minus iz upon 2i. So put sine z equal to pi by 4 plus I in above. So we will get e to the power iota pi by 4 plus I minus e to the power minus pi by 4 plus I upon 2i. So on solving this, we will get 1 upon under root 2 plus iota 1 upon under root 2 into e to the power minus 1 minus e to the power minus 1 over root 2 minus iota over root 2 into e upon 2i. So on solving this equation, we will get 1 upon under root 2 e plus e inverse upon 2 plus 1 upon under root 2 I e upon sorry, e minus e upon 2. So from here we can see that no question, no answer is matching from our answer. So there will be no answer is correct from this question. Now come to the another question. So this is from mechanics. On you have heard that F equal to ma, and a is acceleration, and you have seen that xt is the position vector. Then x dash t, what is x dash t? X dash t is equal to speed, and x double dash t is equal to acceleration. Then so from this equation we can compare f dot equal to m dot a. So a equal to e to the power minus bt. So now we have to find a position vector. So that is x double dash t equal to e to the power minus bt, it is given, and also x dash t 0 equal to 0 and x 0 equal to 0, it is also given from this initial speed and position as 0. So integrate this equation, x dash t we will get, and this will become e to the power minus bt upon minus b plus c, and put t equal to 0, we will get 0 equal to minus 1 over b plus c. This implies c equal to 1 over b, that is x dash t equal to minus 1 over b e to the power minus bt plus 1 over b. Now again integrate this equation, we will get xt equal to 1 over b square e to the power minus bt plus 1 over b t plus c2. So again apply x0 equal to 0, we will get c2 equal to minus का 1 over b square. Put this in above equation, we will get xt equal to 1 over b square e to the power minus bt plus 1 over b t minus 1 over b square, which is b option is correct. No, it is d option is correct. Now come to the another question, which is from geometry. So this question we will go by option. So put if a line passing through any point, then it will satisfy at that point. So for first point minus 1 and 3, 4 and minus 2, both point will be satisfied by that line. So for first option y minus 3 equal to x, put x equal to minus 1 and y equal to 3. So no, this is not the option. Similarly, this is not the option, this is not the option, this is not the, that's why there is no answer is correct, and question also has been dropped from the question paper. Now come to the another question. I will give hint in this question, and try yourself. The equation of polar is given by hx plus ky minus 3 by 4 x plus h plus 5 by 4 y plus k minus 7 by 2. If h and k is whole. Find the value of h and k from here and from this equation. First option will be correct from this question. Now come to the another question which is also from geometry. In this question, he has asked about eccentricity of equilateral triangle, equilateral hyperbola. So in general, eccentricity is given by e equal to under root a square plus b square upon a. But in equilateral hyperbola, a equal to b, so e equal to under root a square plus a square upon a, which is equal to under root 2. So D option is correct. Now next question, this question is from linear algebra. You have heard about Cayley-Hamilton theorem. The theorem states that if fx is a characteristic polynomial, then f of m equal to 0. So first of all, find the characteristic equation, that is m minus lambda I, determinant of we will get lambda q minus lambda minus 1 equal to 0, which is your characteristic equation, that is f x equal to x square, sorry, x cube minus x minus 1. So now replace f x by m, which is equal to m cube minus m minus 1. Instead of 1 we will get identity and equal to 0 according to theorem. So now our equation is this, mq minus m minus I. Now we have to find inverse, so multiply this equation by m inverse. So this will become m square minus identity and minus m inverse equal to 0. So transfer m inverse that side, so we will get m square minus I equal to m inverse. This will be the answer. So your answer is B. So you can see by Cayley-Hamilton theorem, it is very easy and time saving. But if you want to calculate m square then minus I, then it will be difficult for you. Now come to the another question. It is given that del f dash over del x dash. So no, sorry, this thing you have to find, and f dash is given that del f x comma t upon dt, and x dash is given that dx over dt. So apply del f dash over this again. So you will get del square f over del t square, and now sorry, del t, and del x over del x dash over, you will get the d square x over dt square. Put this and this above, so you will get del square f over del t square over del square x over del t square. This will cancel out and you will get del square f over del x square. So you D answer will be correct. In this question, you have to just calculate A, B, C. First, you have to multiply B and C, and then A. So you will get, I think, fourth option is correct. Now come to the eigenvalue of this matrix. So you know that the sum of eigenvalues equal to trace of matrix and product of eigenvalues equal to determinant of that matrix. So sum of trace, first we have to find trace. Trace is equal to 7. So find which one, which pair sum is 7. So here 3 plus 4 equal to 7, and this will not because 1 plus 2 is 3, and this will also not. So either this will true or this will true. Now find the determinant. Determinant will be 10 plus 2, which is equal to 12. So now product of the eigenvalues, 3 into 4 equal to 12, and 5 into 10 equal to 10. So this answer will be correct. Now come to another question. Here we have to find only determinant. So expand this determinant with respect to first row. So you will get 4 minus plus 3 minus minus plus 2, 2 plus 12 plus 2, 1 minus 8, which is equal to 35. Now come to the another question. So here you can see that you can write this equation equal to 2 minus 1 minus 3 4 x by equal to minus 8 minus 1. So first you have to find determinant of this matrix. So you will get 8 minus 3, which is equal to 5. Now in Kramer rule, you know that delta 1, what is delta 1? Delta 1 equal to Kramer rule. Delta 1 equal to, in first place you have to replace by this vector, and another one remains same. So you will get minus 32 minus 1, which is equal to minus 33, and delta 2 equal to, first row remains same as it is in 1, and second row you have to change minus 8 minus 1. So you will get minus 26. So x equal to delta 1 upon delta, and y equal to delta 2 upon delta. So it will get, you will get minus 33 upon 5 and minus 26 upon 5. This will be your answer. No, here also no answer is matching. So answer will, this is your answer. Thank you for watching.